Okay, we're going to go ahead and graph some nonlinear equations by plotting points. These equations down here are nonlinear equations because a linear equation is when the variable is to the first power, and these have a variable up to the second power. So on these equations right here, p is playing the role of the y variable and the vertical axis, and t is playing the role of the x-axis, the horizontal axis. So let's graph this first one, p equals t squared, and on that equation, p equals t squared, we're thinking like the p is playing the role of y. So this, I'll just put a little y here, and this is like x. So it's like graphing the equation y equals x squared. Okay, so let's go ahead and put the -3. You can put any numbers you want in for t. I usually pick numbers that are close to 0 unless the equation makes me feel that I should put in a different number. Maybe there's a fraction or something involved. But let's go ahead and put in some easy numbers in here. Now this will give me more than just this line. This is going to give me a curve. And the name of this, anytime you have a nonlinear equation and the variable is to the second power, that's called a quadratic equation. So let's go ahead and put these numbers in. Again, you're free to put in whatever numbers you like. Putting in -3 in for t, -3 squared, that quantity, -3 squared, you can see that's -3 is going in there for t. Well, -3 squared is 9, so that would give me 9. When I substitute -2 in there, -2 squared is 4. -1 in for t, that quantity, -1 squared is 1. 0 squared is 0. Substituting 1 in, 1 squared is 1. 2 squared is 4, and 3 squared is 9. And now we just need to plot these points. And I see on the x-axis here, I'm going as far left as -3. -1, -2, -3, and on the right, out to 3, 1, 2, 3. And plotting a few of these points, well, at -3, I'm at a height of 9. I see 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 5. So here's my first point, -3, 9. My next point is at -2, 4, -2, then up to 4. Next point's at -1, 1. Then I have a point at 0, 0. Just going through these. Another point at 1, 1. Another point at 2, 4. That's over 2, up 4. And another point at 3, 9. And if I draw a curve through these points, then that curve is going to look like something like this. Now it will continue to go up steeper and steeper as it goes on both sides, and the name of this graph is called a parabola. Again, the second powered equation is called a quadratic equation, and its graph is called a parabola. That's called a parabola right here. I'll write that up here, parabola. Let's go ahead and graph the next one. Another one is let me get a little bit of room here to do this. The next one we're going to graph is p equals -t squared. Okay, so I got the same points in here. I'm going to plot the exact same points. So now if I put the -3 in for t, I would have, well, p equals, I'm substituting -3 in for just the t. So that negative is still there. I'm substituting the -3 in for t, that gets squared. Well, -3 squared is 9, and the negative of that makes -9. Same thing's going to happen when I substitute in -2. I'll get -4. Here I'll get -1, 0. Now how about 1 if I substitute 1 in for t? Well, 1 squared, you see, you do your exponents first. 1 squared is 1, and the opposite of that is -1. Well, the same idea, this is going to be -4 and -9. So if we plot this curve right now, we would get these points. One point's at -3, -9. So -3, -9. So we go down 9 here. 1, 2, 3, 4, 5. So right here is -5. See, this is -1, -2, -3, -4, -5, 6, 7, 8, and here's -9. Plotting these, -3, -9. Here's a point. There's a point at -2, -4. I'm just going through these points here. -1, -1 is a point. 0, 0 is a point. 1, -1 is a point. 1, negative 1, 2, negative 4, 2, negative 4, right about here, and then 3, negative 9, right about here. And if I graph this, you get a parabola that you say is opening downward, is how you opening down like this. So you get basically the same graph as this one, except just reflected. It's a mirror image or a reflection through the x-axis. And this would also be considered a parabola right here, opening downward. So when the leading coefficient, the number in front of the variable that's squared, when that's negative, you get a parabola that's opening down. And when it's positive, you get a parabola opening up. For example, the equation, let's take a look at it. Another one here. This one, p equals 2t squared. Well, that's going to be a parabola opening upward. And you'll find out that it will be a thinner parabola. This one is a parabola opening downward because the leading coefficient is negative. And if the leading coefficient is bigger than 1, then it becomes thinner. Like, for example, this leading coefficient is 1. This is bigger than that, so it'll be thinner opening up. Leading coefficient is negative 1. Here now negative 2. Well, I know negative 2 is not bigger than negative 1, but if we think of the absolute value, just the 2 a second, that means it's going to be thinner. The negative means it's going to be opening downward. This positive 0.5 t squared means that it's opening up, and it's going to be a little bit a fatter parabola than this t squared. This is going to be a little bit thinner opening downward. These are also still parabolas. You just have to plot the points, and maybe this vertex point, that's the point right here, it doesn't always have to be at 0, 0. It might be shifted around here.